Hi. Just as a heads up, has everyone registered already in the Copernicus data space ecosystem? If not, maybe you should, yeah, maybe you should go and recover the registration because we're gonna need it for some parts of the tutorial. You can go to the repo for EOPF sample service if you want. From there, you can find also instructions, isn't it? I remember. Here, right? You can go through this. Okay. True. Yeah, here, also in the tutorial description, you can register here for the Copernicus Data Space Ecosystem. Good afternoon, everyone. Are you all ready? Have you already registered to the Copernicus data space ecosystem? Just in case you have not, please, you can follow the instructions in the landing page of the tutorial. But if not, well, welcome. My name is Gisela Romero, and I come in behalf of the EOPF toolkit, and together with the EOPF Sentinel sample service. With Constantine, we're here to presenting you the EOPF sample service getting started with Zarr. We have 4 main objectives in this tutorial, which is, if you're new, introducing you to the cloud-native workflows and trying to comprehend on the reasoning of why ESA chose this approach for the new EOPF framework. Also, some data discovery with Stack, and also the introduction to Stack catalog. Also presenting you the newly developed plugins in this project. So for accessing Zarr data into a much more efficient and easier way through different tools. And also building some practical data analysis skills. We will dive through Python and a series of Jupyter notebooks that will allow you to an introduction to this new way into discovering data, and that will also set the seed for you to replicate the traditional workflows that we are already familiarized with the Sentinel missions. Here's an overview of of today's session. We're intending to make some exercises and also some breaks, so don't think it's going to be all in a row.
So if you go back to like the registration, I just want to make sure that now everybody's logged on, basically. Go a little bit up before the agenda. So here, so you are on this page, right? You have the account, and you can log on to our Jupyter Hub, because we're going to work on the Jupyter Hub now, and you will find all the notebooks there, which we go through today. So I give you 2 or 3 minutes. Just go through.
Yeah, you can click here for the registration just in case. Also, here is the link. And once you click there, you just get in your credentials and you'll be fine. Like that. Okay, so I think we're good to go.
Yeah, I guess you can move on because the first part will be introduction anyways.
Yeah. Okay. If not, we'll provide some help afterwards. So we want to welcome you to Getting Started with Zarr. For this introduction, I will guide you through the challenges of big data, an introduction to about cloud optimized formats, the reasoning of EOPF, why EOPF chose Zarr for the encoding structure, for providing Sentinel data, and also the specific Zarr structure and how it stores all the data from the Sentinel missions. And as I think we all know, we have all used the traditional safe format that was designed to store Sentinel data. And on the past years, we have realized that the amount of data is increasing, and then we are looking forward for a much efficient, faster, and flexible way introducing all these big data into our workflows. So for addressing the challenges of downloading data and local processing that could be really, really heavy for Earth observation workflows, the cloud-based workflows seem to address these challenges into processing and also allowing us to retrieve much more data to describe in a much more real way the current state of Earth. For this, there's this also this shift into the fair data principles, which are looking forward to the reusability of data. And sorry, I'm a little bit nervous. And cloud optimized formats allow us to retrieve data in a much more efficient way and also process it. And I need 1 minute. Thank you. Sorry. Okay. So cloud optimized formats allow us to process data in a much more efficient way. and also allow us I need 1 minute, please.
Okay, so yeah, so basically what ESA tries to do with the new EOPF format is going from the save file for Sentinel-1, 2, and 3 to the new Zarr file and putting all the stuff like auxiliary data, all the different spectral bands into basically one file, which you then can just open up and access it through a certain data model. Then it is cloud optimized because it's Zarr, so it's chunked. That means if you just want to have a small cutout of this file, you can just request that little chunk of the data, which makes it way more, well, performing better than the other formats, basically. So what we do in the EOPF sample service is basically we have a test run. So we take Sentinel-1, 2, and 3, and we get this conversion Python module from another project. We transform the save format into the new Zarr, put it on the cloud, and make it available to the public. At the moment, we have basically a rolling archive of the last year, and we. Would you like to continue, or?
I can take over from Zarr.
So we have a rolling archive of the last year, which can be accessed. Would you like to go deeper into the Zarr one?
Yeah.
Okay.
Yeah, sorry for this one. But yeah, well, as I mentioned earlier, the Error Observation Processing Framework intended to introduce Zarr as the cloud-native approach of data presentation for the Sentinel missions. The importance and the relevance of this format is that it allows us to hierarchically organize data. It's also self-descriptive as it's based on the metadata that describes all the data encoded with it in it. And this metadata allows us to specific retrieval of information we need. Also about chunking is that this format allows us to chunk, that it's partition data into smaller pieces. And this partitioning also allows us to locate specific data within an area. And this allows us not to download the whole scene. We can just access the data we are interested in. And this also has to, this is, sorry, you can see the results of this chunking in reductions of data latency and also reduction into the storage amount of, sorry, into the storage we are retrieving in our computer. Also, these strategies allows us to compress this data within the diverse formats, and also this compression enables also reduces data latency, and also allows us to store this data in other places we need once, in case we need to reuse it in a further step in our workflow. And also the parallel in and output computing, which allows us to process different chunks at the same time. Why? Because sometimes when we are doing some analysis into a specific area, the same processes need to be done over different chunks. And we can think of the Zarr encoding as a file stored in our system. Inside the root, the general root, that would be the Zarr, we have several groups that always have an associated metadata. This metadata can describe which information is stored, the geolocation, and also the chunking strategy they may have. Once we go inside any of the groups, we have individual arrays. Here's where the multidimensional advantage of storage from Zarr comes. And each of these arrays, again, have a specific metadata that would allow us to retrieve the specific arrays we need. And inside each of the arrays, we can have the chunking strategy. we'll also introduce it in a further step. And they also have some metadata associated. So these metadata will always allow us to browse through the data and only retrieve what we need. So we don't have to bring it on disk from the beginning. And this is a much more detailed overview. So as we can see, we have the hierarchy level, all our groups, inside groups. We have, again, our arrays, and inside each of the arrays elements, we have all of the chunks we are interested into. And then, yeah, we can always retrieve the metadata. This, for example, allows us to know the chunking shape. And as inside this metadata, also coordinate reference system and locations are stored, we can access through a series of conditions the data we need. And we have realized that lately there's not much information about chunking, or it's really like technical or high level. But for Earth observation, these chunking strategies allow us to, as I said before, retrieve only the specific data we need from an area, but not only area. For example, if we're interested into a time series analysis, then we need to find a compromise between the chunking strategy we need. For example, if we want to make a time series analysis, we need the time component to be as real as possible and as real as possible. So we would chunk over the space. Whereas if we're interested into analyzing a scene and specific information and retrieving specific information from the changes that have happened spatially, then we would chunk over time because we are interested into the real state of the space. So we can say that for Earth observation data, chunking could influence a lot the multidimensional complexity of missions. As they have, for example, as they present several dimensions and several temporal and spectral dimensions, and they have also specific patterns. Also some scale characteristics as, for example, Sentinel-2 mission produces approximately 1.6 terabytes, and allowing us, the chunking strategy allows us only to retrieve a specific area. We don't need to access the whole scene. I also said accessing patterns. As for Earth observation, sometimes the access patterns for data are replicable, so we can do that parallelly over specific chunks. And also heterogeneous resolutions. As we know, we have multi-resolution imagery. We need to find a compromise that could chunk the whole scene and all the layers of it, let's call them, into a way that it's efficient for all the resolutions. And as we were talking about groups earlier, we can then introduce the EOPF Zarr structure, and we can define our starting point as our Earth observation product, whereas it's a Sentinel-1, Sentinel-2, or Sentinel-3 product. And inside, it has 4 main groups. Of course, the attributes that are always stored with metadata. The measurements would correspond to all the variables that the sensor retrieves. Also the quality that will allow us to find some information and mask out pixels that we are not interested in. And also the conditions, and this group stores mainly all the information of the state of the satellite while the retrieval took place. And just as a glimpse, here you can have an access of the code if you're interested into looking deeper in it. For Sentinel-2, we can see here the structure. We have a group conditions. Inside, we have the geometry and the mask, and for each of the available resolutions, a group. And in all of these groups, we can find the actual data. And also some other information about meteorology. We have also the measurements group, where we can find the actual reflectance values, again, by resolution, the quality masks. We can also have the access to the quick look. And we finally have the attributes group, which stores the metadata, which other metadata mainly focuses into the geolocation, cloud coverage, and specific retrieval complementary information, and the stack metadata. That it's important because this will allow us to find and to specifically retrieve this item within the stack catalog. So to sum up now, we can say that through the new cloud-optimized approach, there's a paradigm shift from geospatial data, and also that enhances the retrieval and the replicability of the workflows. We can say that Zarr was presented as the cloud-native solution for the Sentinel missions that will allow for a much more efficient retrieval way. And we can also talk about the chunking strategies that are critical for performance. We will also further introduce the chunking strategy that ESA chose for these missions, but they are still under development. And once, for example, you're interested into specific chunking strategy, this format also allows you to choose the chunking strategy we're interested into. And with this, I would like to introduce the second part of the tutorial, which is the stack catalog. And has someone heard before about the stack catalog? Yeah. Okay. Well, for whom not, the stack, it's a community standard base that allows data, geospatial data, to be cataloged, and its origin comes from the intention of geospatial data to be available and findable by users, because as we have already seen, we have a lot of data, but if it's not available, we cannot really make a nice use of it. The stack has also a hierarchical structure that aligns well with Zarr and cloud-optimized formats. And for us, we can see the starting point of stack as the main root of our system. Inside this catalog, we can find collections. Inside all of the collections, we can find several items, and inside each of these items, we have assets. So if we see it, it's also it's a little bit similar to the traditional SAFE format, and also aligns well with the intentions of Zarr. And we also need to remember that the asset, it's always the smallest item, it's the smallest element that we can find within a stack catalog. And mirroring this reasoning with the Zarr format, we can define that our catalog will correspond to each of the Sentinel missions. To the Sentinel missions. Inside each of the collections, we will have each of the available Sentinel products. Inside our items, we will have each of our Zarr encodings. And also here I would like to mention that for now, in the way this EOPF framework is taking place, one SAFE file equals one Zarr item. And inside each of these items, we will find the assets that would correspond to the groups that I mentioned earlier. And not the group, the items, the array, sorry. And each of these arrays will have this structure that will allow us to retrieve them further. And for our EOPF stack catalog, the starting point will be well, if you click here, yep, we will find the landing page that would be the root of this catalog. And we have three main sections. We have the API URL section. This section here will allow us to retrieve it into a further step with Python. Also, we have the search bar and the collections display. And here, for example, we have some information through the API, the source. This area allows us to retrieve it with the specific ID through Python and other programming languages. And with the search bar, we can search among the catalog, our collections, but here we can see them all in a glimpse. In other Stack catalogs, we have much more collections, so we can be really specific. And for example, if we are interested into, we can go to Sentinel-1. And here we have another landing page. If we go down, we have all the description of this collection. And we are able to browse it. For example, we can go up, we go back to our starting point, and we can go jumping into all the collections we're interested into, or a specific one. Let's say we go now to Sentinel-2, and we are able to filter the collection. We can define a temporal extent. We can define a spatial extent if we're interested. Also, we can filter depending on specific specific metadata we're interested. And all these, and this is what we meant with the associated metadata at several levels of our groups. It will allow us only to retrieve the data we're interested into. We can make an example. We're in Riga. So if we define a temporal extent, let's say early this year, sometime between April, May, probably, we need to define our area of interest. We can go much more specific in the, it's here. And once we click submit, we can see a response. And here we can see the found items. We can change the amount of items we want to, we are able to see. But for example, once if we make we zoom here in the area, we can see all the items that were retrieved spatially, depending in the ones we're interested into. And we can also select them. We can either select them here or select them specifically there. And for example, once we go, now we're in this level in our interested area. Now here we can see where the item was found. And also we can see all the displayed information, the metadata. And the important part of this catalog, we can see that it's really user-friendly. We are able to see where this item is stored inside the EOPF catalog cloud. Sorry, in the cloud. And here we can copy the URL for a further retrieval in a programmatic way. And if we go back here, we can give you 5 minutes if you want to try and test out this browsing the Stack catalog on your own. And here are provided some time frames. You can set an area over Sicily or over Vienna, whatever you're interested into, and try out browsing the Stack catalog for if it's your first time, the first time. And if you have any questions, do not hesitate to ask.
Quick question on the Zarr, if you can go back to the
This?
we see at the moment we have the surface reflectance 10 meter, and is labeled, and you data, reflectance, dataset, and Zarr, okay?
Mm-hmm.
Now, which is your concept of dataset?
Oh,
So the dataset means that it can be opened as an X-array dataset. It can be opened as an X-array dataset in the Python world. The data model X-array dataset. Yes. Yes.
But it is an asset. It's within the assets of the item of the stack catalog.
Yeah, it is one asset. If you could you open the 10-meter one? Yes. Can you go to the 10-meter one, or I can just take over if you want to?
I mean, what you just said is basically true for all the layers we saw there. You can open all of them
Correct.
as data sets, so there is no reason to label only a few as data sets.
No,
All data sets, if that's the definition.
no, this is not true. The product itself, the Zarr one, is a data tree. And since this is a data tree, you cannot open the oh, shit. Sorry. I hate Mac. Here, wonderful. The product itself is just data and Zarr.
Yes, but all the bands, everything, I don't see why that should not be equally a data set as the surface reflectance. What's down there are data sets, right? Ah, that's what you mean. Yeah. Why they're not called data sets?
Which one now?
All the ones in the middle, basically. I didn't go all the way down, but even water vapor is a data set.
Oh no, they cannot be opened with X-array because you have the data tree, and then in measurements you have to group 10 meters, which is a data set where you get X and Y axes. And in the 10 meter, you get the bands 2, 3, and 4, and 8, because these are the 4 bands which are in 10 meters in Sentinel-2. But then they are in a subgroup of the Zarr. However, the coordinates are lying on top, like one level above. So you can open up the band itself with the Zarr Python library, for instance, but you don't get any information on X and Y. But you cannot open it up as an X-array dataset.
Which is artificial. Just because that's decided in the way you organize it, that's the kind of data you could.
Yeah, but
I
with
don't see any difference in the nature of the data that you have in a water vapor channel compared to the ones you have in a surface reflectance channel. It's both data sets.
it's only tags to help the user to understand what can be accessed with what, because you can't just access everything, like each band with
Make it accessible if you would choose.
with certain plugins, yes, but not with just if nothing is installed and people think they can use the normal Python stack and then they try to open it up.
So it's a data set definition that depends on the capability of the respective system. It's not a generic definition. And it might change over time.
I hope it doesn't change too much over time. It's
I mean, if you install your plugins, you can change it.
oh, you mean how the data is presented as a data model? Yes, that can be changed. I thought the format itself.
But the data set idea, meaning is then not stable, and I think that's maybe not very...
So you would rather say as a recommendation removing the tags because they're confusing?
I would not call that data set, because data set has, to most users, a different
Okay,
meaning.
good. Yeah, Tina?
So maybe the data set in this case is the original file format of data tree. We should call it as data set because that's correct everything. And then the data set itself is the data tree. And maybe it's more simpler that if we see this data set representation on the Jupyter notebook afterwards, then maybe it's more clear about this data set point of view. And yeah, it is a Zarr, but it is a data tree. So if we look at the data tree, yeah, that's. Pardon?
It's a group again.
Group and arrays for the elements.
Yeah, the bands are arrays. And then the group is like a 10-meter group.
So there is a name of X-array data set, name of X-array like a data tree, but what Peter is saying is more like your definition of data set might well represent it in this way, the name the data tree maybe. And if we look at this notebook at the point of that they will show on the data tree, maybe you can tell us that if that fits with your definition of it.
Behind the data format is Zarr, and technically would be independent of Pixelate to open it, right?
Yeah, would be also now.
And then you don't have the notion of
From this discussion, I also kind of realized maybe we should more focus on Zarr format and use terminologies from Zarr because that's the format, and not working with a data model itself. Yeah, I will bring that into the consortium. Thank you.
You know, I have a question. I was trying to download this Zarr, but I have always I'm getting an error. That
Yeah, yes, sorry, this we know. This button is wrong. Yeah, so it's not working yet.
And actually, what you mentioned, it's the stack catalog itself for now, it's can be seen as a tool for a visual exploring because, yeah, like the Zarr format, it's a data tree. It enables all the data to be hierarchically organized, and maybe, well, you will see also in a further step how the data is organized within. But well, if you were successful, you would have already gotten some items over the areas of interest, and then we can jump into the next part where you need to use where you need to access the the Jupyter Hub, and this will allow us to run the Jupyter notebook that we have prepared for this part of the tutorial. Yeah, we can.
So to get the repository in, you basically just go to the GitHub page. So if you go back, where do we find, at the top one? So here you see this button, GitHub. This brings you to the actual repository. And then you just clone it with the HTTPS. You go over, and via terminal you do a git clone, and then you get all the notebooks into your workspace.
And if we can wait 2 minutes, and once everyone has had the Jupyter Hub clone, the Jupyter repo clones, sorry, we can start going through the notebook. Does someone needs help? Yeah, here you can go here, and here you can copy. But well, if you have already cloned the repo, you will find this folder. Inside the folder, you go to tutorial, and here, if you want to run and follow along, it's intro stack. And well, with this, we can start this part. For this tutorial, we are willing to introduce you into the programmatic way of accessing a stack catalog. Much more specifically for us now, the EOPF Zarr stack catalog. We call it a stack catalog. If you go to the landing page, it has a longer name, but during this EOPF framework, we have decided to call it the EOPF stack catalog. We can make the import of the libraries. One of the most important libraries here are the PyStack client and also PyStack. These libraries allows us to work with stack within Python. Also Xarray, as this library will allow us to access and generate the structure of the Zarr encoding. And well, some other libraries that are just a default that will allow us to work seamlessly. We have also defined some functions that allow us to have a much more comprehensible overview of the data tree, because if you print the data tree with the default libraries, it can be a little bit tricky to follow along, and it's also really, really long. And some other functions that allow us to create an RGB composite in a further step. And if you remember, I told you that in the landing page of the stack catalog, we have this source, this source link, and this source allows us to connect to the endpoint. Well, our starting point, endpoint starting point of the catalog. We can copy it, and we can place it as our end root, and with client open, we access the catalog. I'm gonna run some cells from the beginning so you can see how it works. We define our functions. We generate our connection. And here, for example, we can access it's like the Pythonic way of having an overview of this page. We have several links. Here they have some like default names that allow us to access several levels of the catalog. With the attribute description of the catalog, we get the description of our catalog, and we can explore all the collections with the definition of once we're connected. We get all collections function. We can get a list of the IDs that correspond to each of the collections. These IDs are the equivalent of, for example, going to Sentinel-1, again to source, and we can see this ID. In a further step, we can access several functions again inside our collection. With get collection, we access the first collection from our list that corresponds to Sentinel-1. And with arguments, we can print the arguments such as keywords, the ID, available links, and also the temporal extent of this catalog, of this collection. And we can find links of interest that allows us to access documentation and other information within the catalog. And with this temporal extent attribute, we can see the availability of data we have. if we run the next collection to explore Sentinel-2, level 2A, for example, we see that differently from Sentinel-1, that has items available from 2022, we have items available since 2015. And the same with Sentinel-3, that in this case, it just started, the conversion has just started some months ago, but it's under development and it's still growing. So if you run this same notebook in a couple days, in a couple of weeks, the archive is going to be extended. And just as we did a search over Riga through the web interface, we can do a search through the API. We define a bounding box for the area of interest and a starting date and an end date. For the format of our time frame, this stack the stack library allows us to even search from the hours of availability of data. So we define our time frame of interest, and with the function search of our catalog, we define, for example, a weekend the weekend search for Sentinel-1. I'm not going to run this cell because it retrieves 21,435 items, and it takes 8 minutes, depending on the time of the day. But, well, I can assure you it works. You can run it yourself, and you will see it works. We can, and this was just a time frame. We can now add the bounding box argument inside this search. We define it as Riga, the Riga bounding box. We are still in the list of collections in Sentinel-1. Once we run this command, we can see that we found 24 items within this time frame that cover the area of Riga. We have the same for Sentinel-2. In this case, we need to change the collection that corresponds to the fifth one in our list. We define our interval, and for example, we can already filter the cloud coverage, and we want all the items that are under 30% of cloud coverage. Once we run it, we can see that we find only 12 items that match this condition of cloud coverage. And we can also change several key query arguments. And in the case, for example, of Sentinel-3, level 2 land surface temperature collection, we can define only near real-time items. And we can see that over Riga, during this time frame that we defined, only 7 were found. So this query argument allows us to, if we, for example, go to this area, retrieve specific information from the metadata. Yeah, it's this one. I need to go here. Several keyword arguments of the metadata, and we can threshold everything we're interested into. And as we saw earlier, also, once we go to a specific item, we see that we have this access URL that allows us to access the data in, well, this Zarr item within the cloud. So the way that we can mirror this in Python is retrieving the URL within the data tree. So we access, for example, from Sentinel-2, the first item that we found in our search, and corresponds to this item. And once we access the item with the ID that was found with our function, we can call the get assets. So this allows us to, if we want to see it also in the interface, to retrieve each of these arrays, the ones you were mentioning earlier, within the data tree. And let me run this cell. Oh, sorry, I need to run this one first. And once we retrieve the URL, we can access this item through the cloud with the Zarr encoding. Also, it's important that we define the chunks, the chunk style that we need. This is the part where we can rechunk it depending on the workflow we want to define. And this is going to take some time, but will allow us to retrieve all the groups. And this is also the data tree we were talking about earlier. These are all the groups that are found inside the data tree that contain the data arrays that we can retrieve then for a further processing. And just as an example, we can visualize our quick look RGB composite that it's stored under the quality group at 20 meter resolution. So this group should be here in quality. We can see that we have it at several resolutions. So it's enough that from the data tree, here we don't have a data set still, we have just the data tree. We can call it with the plot function as well. And here we can access the view of the quick look. And it's all stored within the Zarr. So this is, I mean, if we take out the 8-minute cell, we can see that we did this in just under 3 minutes.
So what is it that you display here? Is that the quality?
It's just a quick look of the scene. Yeah.
But according to some quality, because quick look is quality.
Yeah. It's just to have maybe an overview of what we are what we're looking.
For me, quality is something else. Perfectly.
Yeah.
So what ESA tried to do with this format is kind of standardizing the save format for all 3 missions, and therefore they came up with these 3 groups. Of course, sometimes it's a bit odd, but yeah, they try to fit it into a structure basically, and therefore you have condition, measurement, and quality, and then quality would be the category fitting.
Condition, classification. No, I'm just trying to understand. It's not intuitive at all. I find it. I don't know, maybe someone else, but.
Excuse me, could you list all objects in the path of the product? Like with all files that are there?
Could you?
Could you list, because there are only groups, yeah? But could you list what is in the storage? For these ones are, like we have this one product, how, what?
You mean different Zarr?
Every file.
So one observation is one tree, right? And then each tree gets a Zarr file, and then on top of it you have the stack catalog.
Only one file is under, like, under one group is only one file, but there's more files.
No,
Structure with the 0/0 and so on.
Okay. Yeah, no, this you can list, yes. So if you open it up just with, yes, if you just plot DT.
What is on the storage behind this? I think this is assets, yeah.
So yeah, now you can go down into the groups.
Let's see groups here.
Measurements.
Yeah, all chunks.
And then
File.
so now you have this typical X8 data structure, and now you go to this one, and then you can see the chunks. Click on this. Oh no, this is the other one, sorry. So here you see the structure. So what it loads is like the entire structure. Of course, it doesn't load the data, but you get all the information on the chunks, on the metadata, on the attributes.
Why is that exactly 36 chunks?
We're going to see that in a further step as well. Well, at least we're going to have the overview, but that's the 6x6 grid chunking. The structure is found much more efficient for storing all this data.
If I'm interested in, let's say, the scene classification layer, am I supposed to know where that is, or what helps me in finding that? Because it's a mask, it has
It's
to do with quality and
yeah,
the measurement, so it could be anywhere.
it's actually inside. Yeah, it's the scene classification is inside the quality mask, but
It's inside quality mask. Okay.
it's for each. Oh no, yes, inside quality mask, and depending on the resolution you're interested into.
There should be only one.
That's also the thing. ESA also found, as we have several resolutions, it made sense for the user to only retrieve the one they need. So, yeah, there's already some processing between, before this.
Because here is like this band 2 is 900 megabytes. So in general, the whole product of tile is if you think about this, about 900 megabytes. But the chunk size is the tile size. Yeah? The pixels, 10,000 pixels, 10 meters, so it's like 100 kilometers.
Yeah, 110. It's the
whole
full.
tile is the array of chunk is the whole tile.
No, it's like 36 chunks in one tile. But this is a different question now.
You do not necessarily physically take each chunk.
So when you, for instance, request only a small part here, it will only fetch this chunk for you from the cloud and not the full tile.
But only one band 2 has, for one tile, has 900 megabytes. Because normally, all bands, they have more or less 900 megabytes. You know, the whole product if you download.
So this is like encoded. So as a float 32 or even a float 64, this is just internally from Mixery, but it's stored as, I think it's a and 16, right? And then you have a scaling and an offset. Is that true?
That's what it should be.
Yeah. Yeah. So they're in the encoding in the Zarr, they get the scale and the offset, and it's applied automatically, and then this will be calculated on top of it once you, for instance, plot it, and then you get directly the float integer, the float value.
Question, why we have only two dimension and not three, as we are talking about data that do have time embedded as the information? Is that inaccurate?
No, so at the moment,
Basically create a stack.
mm,
The time dimension, if you don't have the dimension, you have then let's say, reapply the time dimension afterwards.
so
And exactly the same argument for wavelength.
okay. So I would like to say something about time.
One Zarr for one product, you have no time because one product is for one point in time.
So about time first. So at the moment you have one save file, and this is converted into a Zarr. Before that, a save file is just one observation. Therefore, one Zarr file gets one observation. We have a plugin, which will be the next section, which gives you 3D data cubes like basically the Sentinel Hub. This will be presented in like half an hour. Then wavelength, we are thinking about, since we then have the certain processing going on in the plugins, we could easily depict wavelength as an axis. We haven't done so yet because our viewing application cannot work with 4D, and we need to solve or like kind of tackle how to do this at the moment. But yeah, this is possible, and it will come and will be implemented.
One more question, because obviously the chunks don't overlap. But if I remember well, you showed that you inherit the overlap from the MGRS structure. So that's not logic to me. Either you overlap or you don't overlap chunking. So if you apply tiling or chunking,
You mean the tiling of Sentinel-2 overlap?
yeah, when you cut the scenes.
But here it's just one scene. This is within one
Yes,
scene.
but if you cut, that as such represents one save, and the save files overlap with the others. So
Yes.
tiling will overlap, but underneath you apply a tiling go consistently to tiling without overlap. That's, I think, has long been shown to be superior.
I mean, the save files, the save files overlap, and they are there. And at the moment, it's really just a reformatting of the save into Zarr. There won't be any other processing on the Sentinel data.
Yeah, but you will have to redo all the geometry, everything, because the scenes will become smaller if you throw the overlap out.
There is no, the overlap is not thrown out.
Yeah, but you will have to throw it out before you freeze this, because you cannot take it forward. Makes no sense at all.
It should overlap should be exactly the size of the chunk that you can easily.
And that would, well, in that case, it would overlap by one chunk, but how would you store? You don't want to store duplicate chunks. That's nonsense. That's totally against the logic of Zarr.
And I feel like, okay, if we think about it, once we standardize the whole grid, of course, all the, how do you say, all the items are going to be overlapped at some point. And then over that whole generation, then we are going to rechunk everything. And, well, not we, but that would be the important idea of it. So at that moment, that chunking strategy will be defined depending on the area of coverage. What's much more efficient for the cloud? I don't know, like we can say, are we gonna get a chunk the size of a city? Are we gonna get chunking sizes of countries? Like it needs to be, it's a whole process, yes, but for now, the first transition, it's okay, let's change each of the save files into Zarr. Let's test it out, see how efficient it is, and then the next step would be standardizing the whole grid. And I think there's another, the grid.
That's okay for kind of testing the format. But if you present that as kind of what the thing will look like in the future, I hope you don't even think of transforming the whole archive into one-to-one from the save files.
Oh no, no, it needs to be tested in a further way, and also.
Not at the archive scale. We're talking 40 petabytes of Sentinel data.
Yeah, and at some point it's gonna be that double amount once. Yeah, but yeah, but yeah.
This size, 919 megabytes or megabytes. What is this the size of one byte?
This is the encoded size of one band as of load 64, but as said, yeah.
It's not stored.
It's not. Yeah, it's not compressed nor anything. It's the whole array. See,
But this is physical size of the whole array?
no.
It's in memory if you would load it in.
That's the nominal size if you multiply the pixel times the bits.
Yeah, and
What is
this,
this actual size?
it's about in the safe ones where they were about 94 something, and it also depends on it.
It's usually a factor of 4 because it's a even 16, but then there's a compression going on. So when you have a lot of NaN values in a scene, then it's smaller, of course. So it changes from.
Yeah.
But you would store it compressed, right?
Yeah. Like this is an uncompressed size, and also, for example, if you run this same workflow in R or in other spaces, it's gonna give different sizes, but it's just because of the way the arrays are presented. But well, and that's also the thing. The functions we developed for this part was exactly for not having the whole print here, because it's really, really complex, and you can take some really, like, a lot of time retrieving all and exploring the data yourself.
Is it Zarr, again, from the perspective of storing the products, is it, I've heard that it's more efficient than the normal save. Is it true?
Can the person make a question to also have the microphone, because we cannot hear, and then also I think they are recording, so.
Okay. Sorry. I was just asking because I've heard in previous presentation, I think from LPS, that actually Zarr is more efficient in terms of storing data than Safe itself, and here we see the opposite. Maybe I don't.
I wouldn't say the opposite. written readers for SAFE to get Sentinel-2 data, and it's actually fairly complicated to get all the metadata out. You would need to read out XML files, you need to write readers to get angles. Here you just have presented everything. You kind of need to understand the structure once. This is complex, yes, I do understand. But with SAFE, it was a lot more work for me to implement everything that I had at the end. And then the next one is reading JPEG 2000 is a shit show compared to Zarr.
And also, I want to add about this one. It's loading the EOPF Python on the data tree format, but I think the Konstantin's group, you guys developed the one which open it as XRA dataset, where you don't have this tree format. I don't know. I guess you guys gonna show it later, right? Yeah, next step. So I think the next step maybe it might be a bit more easier to see it.
Yeah, and well, following. um, so far we have just seen the quick look. Now we're actually going to process and access the data. So we're going to create an RGB composite. We need to define the bands we're interested into. That would be B4, B3, and B2. And we access them again through our data tree. They are stored inside measurements, reflectance. We're going to create it at 20-meter resolution. So from the data tree, we access this group. Once we're inside, we access each of the bands, because then, like in this group, we access each of the arrays, and we can have an overview. So far, we are just having an overview of the data. We have not accessed it yet. But once we call the X-array values function, we get the data. So if we run this cell code, we can see that we have already gotten, well, it's actually running still. We have already accessed the assets. We run the second part. It's retrieving the values. And once we're there, we can apply our normalization function, and it's going to take some time because so far we have just retrieved the whole asset. We are not cutting. We are not doing we are just making the stacking of the RGB. And here's where it comes also the chunking structure that we wanted to show. With the chunk sizes inside each of the resolutions we're interested into. We can access them, but we see just some tuples and like the sizes. We can access X and Y. And we see we have 6 chunks along X and 6 chunks along Y. And we have the same for all the layers. And this specific chunking strategy was the one chosen because it made sense maybe for the resolutions, like all these, the 20 meter, 60 meter, and 10 meter. And if you go to other missions, you will see that for Sentinel-1, the chunk sizes are just 7 to 9, depending on the item. And for Sentinel-3, it's still under development. But how do you call this one? The X and Y georeference coordinate are chunked in 2 by 2. And that's what we have discovered so far. So if you would like to test also the data discovery notebook, you can go to the IntroStack task notebook, which is here. And you can try out these, modifying these arguments on top. And I can show you here. Okay, so
is there any particular reason why you run the y-axis top down and not bottom up as the y-axis in the coordinate system?
Sorry, can you?
Is there any reason why you run the y-axis top down and not bottom up as in your coordinate system?
It's because.
Such that
That's the,
it's facing north when you plot it. But you can also
yes, but
flip it if you want to.
Oh, like you mean in the? You mean here?
display it, of course, in the coordinate system, but the coordinate system here is represented by the column and row numbers.
Oh,
Which is, of course, not the coordinates, which is kind of an image internal coordinate system. But there you have the choice to go bottom up or top down. That's exactly the same. It's just a convention internally.
yeah, yeah.
It is, of course, much easier if you have the same convention as in your coordinate system, because otherwise you have to always reverse an axis,
Oh,
which is not always trivial to do and sometimes forgotten, and then everything is upside down. So it's just, can be, it's a matter of choice. And I would just say, why don't you choose to have it the other way around, to avoid ever the conflict of mixing it up.
I completely agree with your opinion. I was making an webinar last time and I got completely messed up. And what I understood was like when I look at like all the workflow that people were using JPEG, they were also inversing, which I understood that maybe the JPEG itself was stored in that way, and the person who developed the fast this tool just followed what it was supposed to do.
Yes, I'm old enough to know why all this is the way it is. But it's time to make it practical.
Yeah, I agree.
At the times when we did it like that, there was a reason we couldn't do it any different. But that was in the 80s.
Yeah.
And now we are in the 20s.
Yeah.
And we should learn out of it and make things correct from the start.
I agree with you. And it's good for us to know it's not only us who thinks about it, so that we put one more person who thinks about it, and we are totally welcome, putting these kind of comments like why time is not stuck or why So there is, I think maybe it was already shown in the beginning, but there's something called EOPF discourse channel, and that's where people can comment all of these.
Well, I would, before I want to comment on something, I would understand the argument, and for me, this is a real new step here, and I simply assume that every decision taken there is taken based on a very, very thorough thinking, and that should be documented somewhere. Also, these categories that internally are used, I didn't find any justification for them. It's kind of, if they were falling from the sky. You must have had a lot of thinking about why you call them exactly what you call them. And you should lay that down, and so then we can ask questions. But I don't want to kind of run behind it.
There's like the Franzo's discourse, they have the EOPF discourse. That's the place we should really debate on that. And then, I think Constantine can show the link to this website in the end so that people can really actively debate on that.
Okay, should we move on?
Yeah, I think so. Yeah, this one is the same notebook we presented if you want to have a look at it afterwards, and then we go to the plugins.
Just to complete the story of the reference down, it comes from the camera detectors. In fact, when you read the CD, it's a transfer charge. You start by the bottom. So I had the problem 20 years ago on fingerprint also. It was the contrary. So people from capture define the direction of the rotation like that, and people from data processing are in the
original. It has to do with most of the satellites operating in descending mode, and that means they fly from north to south when they overfly, and that the first line they record is usually the northernmost, and then they record the southernmost line. But come on, guys, that's really.
But frankly speaking,
we are no
you
longer.
just add original, you can lower to your inflow, and so the concept is the point. So it's just a matter of adding optional mandatory.
Yeah, but you can really hide all this under the hood. I don't think that should ever appear to a user. Those times are over.
Okay, I would like to move on. Before coming to the plugins, I would like to show you this web page. So this is part of the EOPF sample service. And what we do is basically having a notebook gallery with Jupyter notebooks, which can be also executed on the Jupyter Hub you're working at the moment. And yeah, we try to get certain examples which are published on CDSE and just show it with the new format, where you can also get the comparison. You can also get different groups if you click. So, for instance, for different Sentinel missions, for different application topics, and also for different tools, which brings me basically to the next section, because we built several plugins to make it a little bit easier to access the new format. So, what we do in the project, maybe I can make this a little bit larger. So this is the overview of plugins, what we built. We basically built the blue boxes. So in the Python world, we have an XAREA EOPF backend. It is based on the normal Zarr driver, which can also open up the EOPF Zarr format. However, it gives you certain functionalities, which we'll see in a minute. Then on top of that, we have an Xcube EOPF data store. So this basically allows you to combine multiple observations, so multiple stack items, kind of does mosaicing and stacking along time, and then you get the 3D data cubes, which we will also see today. Then a GDAL EOPF driver is developed, which can also be used as a QGIS plugin, which we will see today. And then a Julia EOPF reader is under development, and later on we have a tiny prototype for Sentinel-2 showing also the link to Snap and testing this out, how the new format works in Snap. So then when it comes to visualization, as said, the GDAL EOPF driver could be used as a QGIS plugin. Then the Snap driver could be used in the Snap desktop and visualize the new EOPF format. For Xcube, we have an Xcube viewer, which we will see today, and of course, the main platform will be just showing stuff in the Jupyter Lab as we do it with the notebooks. Coming to the XAREA EOPF backend. So basically, it is a backend, so once installed, you just can use import XAREA as XR, and then you can use the two functions, open dataset and open data tree, and it redirects then to our implementation. You just need to specify the engine to EOPF-Zarr. We implemented two different modes. So one is the analysis mode and one is the native mode. So the native mode tries to just replicate that tree-like structure one-to-one without any processing or any modification done to the data. For the analysis mode, we try to kind of give the user something more user-friendly. So for instance, for Sentinel-2, you can just select the bands and the resolution to 10, 20, or 60 meter, and it will represent it as one data set for all bands. And if the band is not available in that resolution, we do a resampling, so either an interpolation if you go down or an aggregation if you go up in resolution. Yeah, this is all to the XAREA backend. We will see in a minute. Then for Xcube EOPF data store. So basically, this uses the stack API. So you specify a time range and a bounding box. It will find all the stack items. We will open up all these stack items with the XAREA EOPF backend. We do a certain mosaicing between adjacent tiles and then a stacking along time, and then you get a 3D data cube for each spectral variable. For the GDAL EOPF driver, yeah, as said, for QGIS, but also it can be used in Rust.io, which uses GDAL driver. And yeah, the idea of the GDAL driver basically giving a link to other programming languages, which still needs to be tested. And as a last point is the Julia EOPF reader for the Julia community. So first we will have the QGIS plugin. So for the QGIS plugin, I don't want you to do this now. This takes too long. I will. So you have a documentation in the repository, and basically a Docker container has been prepared where you have already QGIS installed, and then you can try it out. Of course, you can also just install QGIS by yourself if you want to. This is what I've done. I've run this container basically, and then this gives you a local host with an VNC where you have QGIS. So here on the left, you have QGIS, and I selected one band basically. That's band 4 of a Sentinel-2. By just, yeah, layer, add raster layer. Why is this not working? Is this even responding? Yeah, it's responding. Maybe it needed to reload. Well, I added this band by just putting in the URL, and then it is displayed. Where can I, 1 sec? You just need to specify basically, so this kind of URL you need to put in. This part you get from the stack catalog, which is the URL to the stack item, or like no, to the object storage. And then here with EOPF Zarr : you get the redirection to our GDAL plugin. Okay, then coming to the actual tutorial, which will be the Xarray backend and the Xcube data store. If you want, you can follow this. So you will find this, that's the notebook number 2, plugin Xarray and Xcube. So yeah, both plugins are Python libraries, and they are published on pip and conda, so they can be just installed via pip or conda, or also mamba. Here we just import what we need. It's basically Xarray, then PyStack client for searching, matplotlib just for plotting, and some stuff for Xcube. Here, do a little search like it was explained before to get one specific item. And then, so I extract the href from the product, which gives me the URL to the object storage. And then also, in the stack item, we put an extra field called Xarray open data tree quarks. So in these quarks, you get already that you want to have a chunked data. The engine will be set to our plugin, and the operation mode will be native. And therefore, you can just plug in all the information from each stack item, href, and open params, and this will open up your data tree. So this is basically exactly the same what Zarr does because it's the native mode. It's just a 101 thing where you get, again, the group's condition, measurements, and quality. And then you can access the data by, for instance, plotting it or writing to your local file system or an S3. And here we plot the RGB image at 60 meters. Next, I would like to show you, so we also implemented the open dataset method as a native mode. This is because the open data tree is, or like the data tree data model in Xary is just out since October 2024, and we wanted to give the user the opportunity to also open the full tree as a data set. And basically, in a native mode, it will just flatten the entire data set. It looks ugly, but it gives the possibility to be compatible with workflows which need dataset model, which needs a dataset model. Since this is then massive because you get the full tree, you can also do a certain filtering with the argument variables where you can just put in a regex and then you just get, for instance, only the measurements. You can even specify further. So for instance, if you just want to have the 10 meter, you could do that also with this filter. The more important one in this backend is actually the analysis mode. So here you either say opt mode analysis or it's also the default. So when you would put this out, it will redirect you to the analysis mode. And we take the same href and we say we want to have a resolution of 60 meter. And if you don't specify any variables, you get all the different variables where you have all the different spectral bands. You have the scene classification, the cloud probability, and the snow probability, I think that band is. And they are all on 60 meter resolution. So either if it's available in native, it just drags the data, or like the data structure, or it is resampled. And it's also chunked, and therefore you then have some kind of data cube of one tile. And for instance, for the scene classification layer, there's also further information on on the color code down here, which we can use in the next plotting routine. And then on the left, you get band 8. I'm showing band 8 because band 8 is not available at 60 meters. So the actual resampling is happening. This is fairly slow. Well, normally it's not that slow. I believe it's like the Wi-Fi here then. I'm a bit surprised.
Maybe something crashed because a few seconds ago I did it very quick and now it's not doing it at all.
Did Jupyter have crash?
Too many notebooks.
Yeah, it could be. Okay, then I will open it up locally. Okay, so I open it up locally now. I don't know if you can follow, but you can just look at the screen, and also on the documentation page, you see the notebook rendered. Okay, then I would like to show you the Xcube EOPF data store. So as said, these are the 4 steps. We query, get all the items, open up the items, do a mosaicing, and then a stacking. And then we get 3D spatiotemporal data cubes for each spectral band. And so far, we implemented that for Sentinel-2 and 3, and Sentinel-1 will be supported in the next 2 months. For this, we, create this instance, like a store instance with the new data store method from Xcube. The name of the data store, or the ID, is exactly the same as the engine in the Xarray backend. Then we specify the bounding box and also the CRS and UTM. And we reproject this bounding box to that UTM. And then it's a one function thing, basically. We take the store ID, the store instance, and then we have this method open data. The data ID is Sentinel-2 L2A, so this is the collection name of the stack in the stack catalog for Sentinel-2 L2A. Then we take our bounding box, we take a time range, the spatial resolution which we want to have, and we request the CRS, and here we only want to have these 4 bands. Yeah, also this is a lot slower than I'm used to it, but at least it works. So sorry for that. And yeah, here we get then free timestamps, free timestamps and a 3D data cube. And it is, well, chunked in a lasagna form at the moment, but this can be also specified through the opening method, basically. And then, yeah, we can just plot, as an example, 1 timestamp for the red band. And here you see a picture of Hamburg Harbor and Hamburg City here, over here. The same can be then also done, so you can change the projection, and therefore you also need to change the bounding box and the spatial resolution. But it can basically reproject into any projection which is supported by PyProj. Okay, and as a next step, I would like to persist this data cube. This means that I'm actually downloading the data and save it in the memory because I want to show it in the viewer later. It would be possible to also just present in the viewer without persisting it. However, all the time when you just change something in the viewing application, it would redrag the data. So for small data cubes, you can just persist it in the memory. For large data cubes, you could persist it on your local file system or on an S3, and then just work from there, basically. And now this one we need to execute because we are in the Jupyter Hub. This doesn't need to be done if you're local, but basically we just need to tell the Xcube viewer where, in which environment we're working, basically. And up here, this is basically the URL. You see, we're in a local host. We don't need that here. Right, we changed to local. So I'm removing this, but yeah, if you're in the Jupyter Hub, you would need to do this, and then this is basically the Jupyter Hub address, and then my username of the Jupyter Hub. And then we can start the viewer instance, and the method info gives you where the viewer is started as an application, a web application, basically. Right. Sorry, I changed the cells. We need to add the data set first to the viewer, otherwise the viewer doesn't have any data. So there are two options. What we can do is basically either viewer show. This will give you like a small application in the Jupyter notebook directly. Here you can, for instance, click through the free images. You can do, you can readjust the range. You could, for instance, compare two bands if you want to. You can select the different bands over here, which we have in our data cube, and here you can play a little bit with the data you retrieved, basically. And the same is then possible. I'm not sure if this is, no, probably we need to have an, let me check. If you run this again. So now, here you get it as a full, one-page application in the browser. Yes, I think that is it from the plugin side. Are there any questions? If not, we could have a coffee break for half an hour, and then we continue at 3:30.
Christian is answering, so apparently there is a
let's get coffee. But it was a bit overwhelmed when you were down. Was like, oh my god, what am I going to
kto się trzyma 2 tygodnie. Mniej istotne.
Ten studium jest jakby tak, że coś robię, tak?
Tak, jeżeli masz 14 dni, żeby cokolwiek, jeśli 14 dni nic nie robisz, się nie zalogujesz,
No tak, ale już to używam.
So I think we're going to continue with the tutorial. Yep, okay. So for the next step, we will see an application of integration of several data, of several missions. For this one, we will assess wildfire in Sardinia based into Sentinel-2 and Sentinel-3 data. If you want to follow along while running the Jupyter notebook, it's the one noted as for wildfire in Sardinia. So as you may know, during the wildfire season in Europe, there's a lot of news and a lot of information going around. And one of the most affected areas is Italy. And on June 10th, 2025, in the Nuoro province in Sardinia, approximately 1,000 hectares were burned, and well, regarding the area, we can say that it could be visible from satellite imagery with 20-meter resolution. And as we are willing to demonstrate the flexibility of this format, we are intended to integrate an item from Sentinel-3 SLSTR land surface temperature with an RGB composite from Sentinel-2 level 2A, just as we have seen in the previous part of this tutorial. Of course, we need to set up and import the libraries we're interested in. For now, we are all, besides X-ray, we are already integrating Car2Pi features, so we can georeference and visualize all this data in a much more efficient and digestible way. We are also introducing the local cluster from Dask, as we want to demonstrate parallel computing. And we are also using georeferencing libraries to be able to visualize everything. And we defined a set of functions that allow us to validate the items from Sentinel-2 with the SCL masks. We also developed some functions that allow us only to retrieve the area we're interested into, and some reprojection. So we start by running. I think I need to restart the kernel because I run it. Yeah. And we import the libraries we're interested into. We then import all the defined functions. We are also stored there in case you're interested into having a deeper look on them. And we start our cluster that will allow us parallel computing of the chunks. And as in the first part of this tutorial, we introduce how to connect to the EOPF stack catalog. So we define our connection. Then, as every workflow, we need to define our search parameters to search among the catalog. And we need to define the day of the fire, which was the 10th of June, 2025. And we add an additional day because, as you may know, as Sentinel-2 has a revisit day in 5 days. Sometimes the specific day we are interested into, it's not available. So we choose the closest in proximity in time. And for us, in this case, it was the 11th of June. We also define our bounding box over the area. We define the coordinate reference system and the reprojections as the Sentinel-3 land surface temperature. It's in decimal degrees, so we need to define a reprojection. And we also define a bounding box for visualization. Here, it's the search box allows us to retrieve the specific area, and the mapping box allows us to define a greater area, so we can also visualize the close area of the place. So for this process, first we need to retrieve land surface temperature, because that will, as fire is hot, that will give us a signal of activity, of heat activity in the area. We also need to create a true color composite of Sentinel-2 level 2A, which is the one we have already previously done, but we are now going to cut it to the area of interest, and we need to overlay both of the datasets. So, going over, oh, sorry, I need to run this one first. So, going over our search, we define our search in the Sentinel-3 land surface temperature collection. We define our search parameters. We also query this time near, like the timeless category for item, and we get our response that during this day we find 5 different items over the area of interest. And regarding the time and also the happening of the fire, we will retrieve the first retrieved item of the day. And once we do the request, we get from the newest to the oldest. So to retrieve the first one, to retrieve the first item that was captured during the day, we retrieved the last item of the list. Again, we access it with open the data tree and with the Zarr encoding. And we also retrieve some information inside the metadata that will allow us to have a much more efficient plotting in the next step. And here we can see that we got a response, we got our coordinates, and we have here the data we're interested into. That would be the land surface temperature assets. Then we are now retrieving the whole item, and we need to code it to the extent that we are interested into. So we define a Boolean mask based into the bounding box of visualization and the measurement we're interested into. That would be a land surface temperature. Oh, need to run this one again. Yep. And once we create this Boolean mask, in the next step we apply our masking function that allow us to only retrieve the land surface temperature clip. And once we have the clip of the surface of the land surface temperature, we define. We also clip the coordinate mask, so we can also plot the bounding box inside. In Cartopy. And until this moment, we have the whole clip, and we are only interested into a threshold where we get the response of temperature over the whole area. And and as this land surface temperature is defined in Kelvin, and by some testing we did during the development, we realized that all the data that pictures a temperature over 312 K was spotted inside the area of the fire. So we defined the threshold. And so far, to have an overview of what we were clipping, we also generate a new ramp color for our mapping. And we can see here the response. So far, of course, we still have the pixel values, and we still need to georeference this data. But that would be done in a further step. That's also the reason we define the bounding box over the geolocation and to be able to reproject it in a further step. Then We need to generate also the same workflow over our true color image. And for this, we need to go back to the origin of our catalog. And instead of searching over Sentinel-3 data, we now search over Sentinel-2 data. So we define our time frame, the bounding box, so it would be the search box of the area, the daytime that would now correspond to the next date. And also, to the fire day. But we see that we don't get an answer because of the revisit time of the satellite. So that's the reason we needed to define an additional date. And the closest to the day of the fire was the following day. So we perform again the search. And we see that this time we get a response from the catalog. So we now need to do the whole composite workflow that consists into masking the invalid pixels with the scene cover, the scene classification layer. We also need to clip it to the area of interest. We need to define the selection of the bands we're interested into. We normalize each of the arrays. We create our composite, and then we equalize the composite to have an enhanced view. We again search for the data. We retrieve the available URL we found. We decode it with Zarr. We define the chunking strategy. And we also, again, retrieve metadata that will complement the name of each of the items we were interested into for the plotting. And we retrieve the validation masks from the conditions level at 20-meter resolution. Afterwards, we need to crop the assets for the area of interest. We define also the bands we are interested into retrieving for creating our mask. Afterwards, we need to validate each of the bands we're interested into, and until this point, we are still not accessing the actual data. We're just making the filters, and once we again call values, we bring the data to our disk and start processing it. We make we apply our masks. We define the items and the coordinates we're interested into, and once we get the actual layers for each of our RGB composite, we apply the normalization for them. Now we are processing the data. We stack them to create the composite. We equalize our composite to enhance the creation and all the coloring ramp. Still, we have not reprojected it. It's just an overview to see how it is. Sorry, we have not referenced it, and we have an overview of what's going on. And here we can see an actual scar, a burnt scar, because this item was retrieved 1 day after the fire occurrence. And then, once we define, once we create the RGB composite, we define our area of interest, our projection. We define our first layer of that would be the true color image that we created. We define the extent. We define our coordinate reference system. Then we also define the same for the land surface temperature clip, because we already clipped the data to the threshold we were interested into visualizing. And we can overlay both of the data sets. And just for a heads up, like this small rectangle, yellow rectangle was the searching box we used to locate the scar inside the whole collection, and we can visualize the overlay of both of them. And we see that there was indeed a response close to the burning, close to the to the burning spot. Also, other responses along that may be related and are most likely related to the smoke of the fire that was spreading throughout. And well, so far we were running it step by step, and if we run the last code cell, yeah, we got 600 seconds, but if we run the whole process in one go, it takes from 30 to 35 seconds, depending on the on our connection. And that demonstrates that that this cloud native approach allows us to have fast fast mapping and retrieval of data directly from the cloud, and also the seamless integration of data sets. And this relates this is related to some of the earlier questions, that why was this structure of Zarr chosen? Well, because to be able to integrate several missions and a unified structure also enhances this possibility that we have, for example, all the information from the measurements retrieved from the sensors in a specific group. That makes it like it makes it replicable into different from different perspectives. So if we need to to make much more efficient these workflows, we can just replicate them along several missions. And if you would like to try, and we encourage you to try this notebook, we have 2 other data sets with all the specified, two other fire events with the specified thresholds. Here, for example, for temperature, which were retrieved in other locations. Also the day of the fire, the UTM zones, as you would need to make some changes. And to try it out, you can go to the 04 wildfire task one, Jupyter Notebook, and inside you can change, you have some lines that indicate where you need to modify the code to try it yourself. And I think, how much time? Maybe 20 minutes? Like 10 to 15 minutes for you to try this notebook. Yeah, you can try both of the fire events.
So the Jupyter Hub is working on my side again. Does anybody need support again? Yeah? Or can anybody access it who wants to access it? If not, raise your hand.
Yeah. And if you have any questions, please let us know.
Yeah, it also works on my side. I checked it. Yeah, oh no, I didn't want to. I just checked the Jupyter. Yeah, I didn't want to open Teams now. We just do a wrap up and then I will give some overview. Yes, I was. So at the end, we so takeaways EOPF 101, which is like basic information on the web page. Again, Arnold Gallery. I forgot to put discourse down. It's at the end of the hackathon, and I will explain them like the channels. So I will explain it the channel.
Nie? Przykład, co to było?
Jest chyba ta, że...
No nie padło, ale czy nie?
Dobra, ja mogę podać dokładną lokację.
Dawaj, to dawaj. Widzisz, dwa są.
Gdzie to jest?
No, bounding box search. Masz minus 7,38, minus 7,38. To znaczy, że bounding box to jest no w tym
Piątce?
w Sardynii. Na dole Sardynii. Tak, 0,4 na samym dole. Sklonowałeś sobie to? Co?
Nie, nie.
Znaczy to wiesz, to jak zrobisz git clone tego, co ci wysłałem kiedyś na czacie,
No.
to tam masz tutorials, jest link 0,4. Pierwszy, Sardynia. Na dole,
Ja mam taki, no bo ja...
na dole ten pliku jest bounding box. Widzisz, oni mają dwa tego bounding box.
Jaki jest? No. Nie no, masz 4.
X, Y,
No.
X, Y. Przez dobrą rzecz.
Przez obie tam degree. A to jest XY, tak?
No. No, czyli jedno to jest ten minus, to jest, że to jest półkula zachodnia, a to numerek dodany to jest szerokość.
38, no to tak.
Minus 7. No to gdzieś podkładać, to już zdawało.
Yeah, I think the minus it was just for noting that it was the yeah.
Sometimes we are discussing because sometimes bounding box is more than 2 points.
Sometimes bounding box.
No, but
It's more than just 2 points. You have polygon instead.
Bounding box is mostly 4 points.
Nie, to ja to zrobię, no.
Trzeba dodać do nich trochę.
Wysłał to pierwszy z jakiem.
The task one.
yeah, but I tried it earlier.
Well, this is now one string, so you need to put the
No,
parentheses in between. don't you?
This. No, but if it says yeah, it must be a scholar. I don't know why. Yeah. I don't get through. I was like, why did I have like there? But no, yeah, true. I was like,
It's totally fine. Happens anybody when we code.
no, it's just that I left them out. I left everything out. Oh yeah.
This is the task, so we can actually go
Yeah.
slowly. Then they
No,
also see a little bit.
Yeah, but I mean, we took like 15 minutes, isn't it? So I think we could have maybe done earlier actually.
Yeah, so would like to at the end I will
Jeszcze potrzebuję taki większy teraz do
go
wizualizacji.
through all the resources again because I think it's
No, ja wam
important to know
degree
where it is.
550 metrów.
So I would start from
A teraz jeszcze potrzebuję większy, żeby
EOPF
better
101,
visualization.
showing notebook gallery, and explain discourse.
Jeszcze taki na przykład
Yeah, they discourse. Yeah, because the notebook petition and everything, students have tomorrow.
Jeszcze jakieś parametry tam wpisać? Chyba nie.
Dobra, a daty musisz przestawić na...
2020.
Tutaj miałem bonus, ale to miałem nie dałem.
Dobra, to który?
Weźcie 23, bo to jest 23 kwietnia, 25 nie zróbcie od 22 kwietnia do 24.
Są dwie daty.
A, fifth day?
Tak,
Kwietnia.
a, sorry.
To już może? To musisz zmienić na jedną na... Żeby było może? 23. Fire date? A, fire date. Dobra, to jest 23.
Everybody okay or don't like, agitate to just
Puściłeś to? Dobra, to idziemy teraz.
That's not working again.
No, it's working. I'm just like redoing the second one just in case.
Okay.
Zero side error reduction.
Nie znajdziecie żadnego niku. Ale jest w Zarze? X w processorze jest? Wywodzić?
Co?
X w processorze sprawdzałeś sobie, czy to są nasze przypadki?
To są nasze ostatnie.
Są DL3, tak?
Coś mi tu, ale nie wiem czy to jest to. Coś mi tutaj wyleciało.
Który to mówisz? SSLL, tak?
No. Myślę, że to jest za dużo błędów. Dobra, zrobię restart dyktatora.
Beznadziejnie symuляcja.
Może ci tak musisz, żeby to pokroiło wszystkie. Nie musisz tego klikać.
Odwrotnie trzeba być. Wiesz? Że masz XY
Total items found for Sentinel-2 over tu 0 mi wskazuje.
No tak, oni za dużo nie powinno żyć.
Albo nie ma tam produktów, albo... Listing takes out of range.
No tak, oni za dużo nie produktów. No dlatego, że XY musisz zabrać. Bo oni mieli najpierw długość przeżyłość, ale to już odwrotnie było, ale wszyscy zmienili sprawę.
Dobra.
Nie? Bo oni tam mieli najpierw długość.
Press just Control Save. Sometimes this helps. No.
Don't say. No, I know. Like
Okay.
in the first one, it needs to be the second object because the first one is just like covering a part of the bounding.
Yeah. So maybe you need to close it and rerun it again.
So it's like, no, don't do that. It's this one. Da-da-da, product, search. It's getting... So this one needs to be the first one. I'm using it once.
Oh, but no, you need.
No,
Oh,
yeah,
it's
because
saved. The kernel saved.
because I didn't remember. Yeah, now it's working.
Good.
Ja sobie nie wiem, też nie sobie.
Yes.
Nigdy nie sobie żadnych produktów. Co, co wy? były produkty. Zmieniliśmy 4 na 6. Wiecie? Ten stack nie ma w pełni skierni po prostu. Czyli trzeba robić te programy błędy. Po prostu z tego się wszyscy wybrali w Polsce. To polskie rasy.
Should to per index auto, ale czy te kolejne się tam nie.
Wszystko złączone. Jak podam czerwiec, wygląda tam tyle czerwiec, myślę, że tam nie miałem danych po prostu ich stałych. Jak takie podałem dane, przepraszam, to wtedy poszło. Ale z tym paciaszkiem po prostu. Mieszane, to sobie robimy podstawową formulę, tak. Podwójne terminal, tutaj to społecznego. Tu błędy w tym. No zaraz mi 3 zrobię, wtedy kurczę. Zrobię się zaraz. U mnie działa.
So how's everyone doing? Were you able to replicate the workflow? Yes. Well, just to follow up, I'm going to go over the second workflow, which is the fire in Spain, in Cáceres. And if you realized here, you needed to add the fire day by yourself, as we had 2 different images, because for the specific day of the fire, there was not available image. Here, we needed to change the UTM zone. With the one in Sardinia, it was 32 UTM zone, so we go to 29. And in this case, for example, in the first retrieval, we got 5 5 items. Here we got 2. And we also changed the threshold to 325. We clipped the asset. We created also the new visualization bounds here, the breaks again. And we again once more search for the image on the day of the fire. We got no response. We add the other day defined, and then we got 2 images. If you run it with the first item, you got no response because the first item only overlays a part of the fire, so you need to go to the second one to be able to crop the entire image. And once we set the second item, we can generate the visualization. We generate the overlay, and here we can actually see much more spread across the area. So there was more more smoke going around during the time of the fire. And if you run it on a series, this one took 44 seconds for retrieving two different items from two different missions. And yeah, so here, from this workflow, we can conclude that the current approach of retrieving items directly from the stack catalog enables a faster way to assess a wildfire, to integrate also two different data sets into one visualization. And then from this tutorial, we would like to enhance once more the importance of cloud optimized formats and highlight the option that ESA is now providing us to retrieve data directly from the cloud through Zarr, and all the ongoing developments that are being held, such as the plugins presented and also several resources that are encouraging the community to have a smoother adoption of this new format. And well, we would really like to encourage you to try out other resources that we as a consortium are developing, which will be introduced now.
So yeah, I would just like to give you a quick overview. Well, where to put questions, where to find information, basically. So there's this project, EOPF 101, where also Gisela is part of. They give you basically a background on the Zarr format. It's more like for beginners, I would say. It's written in a way that, yeah, it starts from the beginning if you don't know anything. Web page is over here in the documentation as well. Then what we've showed you already is the EOPF Zarr sample notebooks. This is this gallery. We will add more notebooks. It's basically a replication of the CDS notebooks and some other add-ons from our scientists where they think it might be useful. Science cases, basically. I put in more in-depth notebooks on the plugins, trying to get through all the features of the plugins. You've only seen a little bit of it today because of the time. And then another resource which you can use, I will put it also at the end of the tutorial, but now it's only at the end of the hackathon. So firstly, tomorrow we have the hackathon. So we meet for a full day hackathon. If you want to try and work with this data on your own designed use case, we have already, well, made some suggestions on the use cases which could be picked up, but you can also just come in with your own use case. Just to remember, so the EOPF sample service, it's a trial of this new format. So what we do in this consortium is we take the software, the CPM software, we convert Zarr, safe into Zarr, we store that on the cloud. It's a rolling archive of about the last year, I would say. And it's still in the, in the growing phase, basically. It's not the full year, which is available for all three datasets. But for Sentinel-2, it's pretty much available. Sentinel-3 is also quite good. Sentinel-1 is still a little bit sparse and will come up till end of the year. Then we have the stack catalog, which is also done by our consortium. We have this notebook gallery, and we have the plugins. So yeah, if you want to hack with us tomorrow, you can come here at 9. It will be in room 401. And if you have questions or, I don't know, suggestions to make this format better, because also we on our consortium side, so we work closely with the CPM consortium, which is the actual conversion software group. And we, for instance, found certain errors in the new format, and they tried to fix it. So if people try it out more and find more errors, we will have a better format at the end. If you want to have, well, suggest something else, I believe they won't accept like large changes, but like small changes they're happy to take and fix. So here's the discourse. If it's related to the actual format itself inside the data, you go to the CPM one. That's the core Python module, so that's the library where save is transformed into Zarr. So this is basically also the channel what we use in our consortium when we raise some issue. There's also GitLab from them, which I will also put into the documentation tonight in the same, which you have already. They can also make some issues in the GitLab, basically. If there's something related to Stack or the cloud where you fetch the data, then it's our consortium. You go to the EOPF Sentinel Zarr sample service. Yeah. Then, as you see here, we have also webinars once a month. They're almost over. I think we only have October, November, December left. Yeah, you can register for them. They're always, I think, Thursday at 2. But it will be, yeah, I'm not really sure if it's like a regular every 4 weeks. It will be announced on the webpage. I also put the webpage link to our EOPF Sentinel service into the documentation. I think this is all what I want to share with you. Do you have any questions on this? Yes.
On some picture you had also stack and Odyssey stack libraries mentioned, but they were not used in the exercises. And as you have multiple bands per asset, then I think there is a problem also. Do you have any suggestion or plan for that?
So we first, Tina? For stack and Odyssey stack, we would need to have a reader, right, to make it possible with the new format.
Well, I am mainly using this, the new one, like the stock example that is on the notebook, which is the one with the EOPF extension.
So the Xcube data store does basically exactly the same what the function stack and Odyssey stack are performing. I'm just thinking, because they are built on, I think, raster IO they use in their backend, and therefore we would need to have probably a GDAL reader, but which gives you a data set, which is not possible at the moment. So it's not part of our plan of our consortium, but that would be the way to go to if this.
Like the goal would be to get a time series, because now what you were showing, you didn't get ever time series. Except this Xcube,
yes, it's only the Xcube at the moment. What you could do is, if you're just interested, this only works for Sentinel-2 though. You could get one tile, get all the time dimension, and then you just stack it with Xarray itself. If you don't want to be dependent on Xcube, that would be the only possibility at the moment, how I could see to have a 3D data cube. Well, it's a new format. We are in the development phase.
That has been taken. Why not have the time dimension and automatically you get the entire...
You can't change it. I don't think that you can't.
Point. You are creating a new approach, and I would like to understand which was the reason to still use the overlaps. Okay, you are mapping one-to-one the X-safe format into the new Zarr, and we already have seen in AWS that element 84 was getting rid of the overlapping area 5 years ago, okay? And you are basically not taking the action of get rid of the overlapping, and these do not facilitate the creation of data cubes out of the information.
I completely agree with you, but unfortunately, it's not us who decided the format. And then this is the what really this EOPF, the discourse that I want you to write about that because.
But they are aware. They are aware. There was
Yeah, but there's a discourse. Write it, and then a lot of people put the push, and then I think that would change the things. And then definitely we will talk to the people that we know on this project on either side. This is, I have exactly same point of view, and I also already told the person who takes over it on the either technical manager, and so these people are aware of it. But I think it's like, you know, the more and more people talk about it, I think that would change have the more possibility to change it fast, I think.
Because just before Peter, it's not against the project, okay?
Yeah, I know.
It's just to make the project better.
That to make the project better, so if more people can write on this discourse, it would help. I mean, this because that's the main part, and we will definitely give what you said, that what was it, EOPF discourse, right?
Yeah, but okay, it's no. Tina, I know how to get. But you can as well report that during the workshop was reported. Yeah.
Yeah, we will write it on we can start right now on the stuff. So with the workshop, we had so many people. How many people think the same thing, right? 1, 2, 3, 4. So how many how many people think it's so useless that there is the edge is in the Zarr file?
Don't call it cloud optimized if you have this bullshit in.
Yeah.
Sorry.
So like about 10 people, right? So how many people thinks it's so unfortunate that time dimension is not in the same UTN? 1, 2, 3, 4, 5, 7, 9, 10. Okay, so that's something we can write first.
Like, it's a different level of abstraction. I think this data what you have has these tiles and overlaps, and then it's another data product where you have it harmonized.
Personally, I don't agree with that because I think because I like the lasagna type chunks, which lasagna with some depth. So, I mean, okay. So who got what, lasagna and so on? Okay, what it's like, do you have pen, right? Like chalks, or how did you write here? You found no, there's no. There's one where? Oh yes. So no. No, not. I mean, so what I so let's say.
This box in the back.
Yeah. Okay, it's a university campus, so that's nice that we have the stuff, right? So what I wanted to say is, so we have like X and then Y, and then but then okay, now this is not a good. Okay. So let's say what. Like you have like X and Y, so like let's say latitude, like our spatial domain, right? But behind we have the time. And what we want to do often is this, what we call as often, I'm really bad at drawing, No, there is not this one. Yes, sorry. So what we often call is that the spaghetti is like, when we want to do the time series, we want to have the same location of X and Y, but want to have all the time and dimension data, and then we want to do the FFT, or, want to see how the data changes in one place. This, we call it as spaghetti, because, like spaghettis, right? Fine? No? Not so clear? Yeah. And then what we call it as a lasagna is like we only have one day of data, but we have all the area of X, Y. So we have a piles of lasagna paste. Like, we have a pile of paper stacked together, and it looks like a box. Yeah, no, not clear for you, right?
Maybe it would be good to ask how many of you are used to the concept of chunking?
Yeah, that's what I'm explaining. That's what it comes in the end. It comes in, don't say it right now. No, that comes in the end. Yeah, but yeah, so when you open one, like, for example, so what kind of data are you working, Yeah. Hyperspectral data. Do you like how you are looking for like one geographical area? Yeah. Yeah. Okay. Okay. Okay, so when you have the so you sometimes use a B02 of Sentinel-2 data or one band data, one band of one image, right? So one band of one image at one time step is this sheet of paper. That's what we say. So like when we have to have a time series, you have to read a lot of these observation, and you just correct this area from each file, and then connect it and make a spaghetti, right? Yeah, which is very, very annoying. But in a sense, if the data itself of somehow you have some x, like we have 100, like 1 kilometer, and then 1 kilometer, but all at the same time, if we have 1 week of data together already, that means when you want to do the spaghetti, you just need to take, like, if you want to do 1 month, you just need to read 4 files for making 30 days of data, right? So that's the concept of why I told you that that I don't think it's a good idea that today for the UTM data, we have just one, we only have one time series. So if we want to have all the data, we have to, and if it's like 30 days, we have to open 30 files, right? So if the time was already concatenated in one file, and then we just need to open like 7 days, and then we just need to open 4 weeks of data. Anyway, that's my point. I'm sorry. I mean, I might have mixed you up. Yeah.
What you are suggesting is to have...
That's my suggestion. That's not what it's done.
Sorry,
Yeah.
to make it more clear.
Yeah.
What you are suggesting is that right now they are storing the data accordingly to the single safe model that
Yeah.
is based on time, let's say,
Yeah.
acquisition.
Yeah.
Okay, so it's separate. And what you are suggesting is to create a data cube out of which you could extract the information. Okay.
Yeah. So.
The first question is how you are going to deal with the multiple requests on the same data cube, because there is the problem that you will have millions of requests at the
Yeah.
same time, and even though it's a
Yeah.
distributed system,
Yeah.
distributed
It's the same. That is the same as that if you have like this chunk size, which is a little bit bigger right now, maybe. It's the number of hit for this or number of hit on total size. It's the same if you think about the size. Yeah.
Which dimension you would prefer to be chunked in the spatial domain or in the temporal domain?
The spatial and temporal on the both side, so that yeah, like medium size, yeah. That's my idea, but I mean, this definitely have to be benched with the different people's use case and so on. I mean, that's what that's what Copernicus Marine Services are doing. So they are providing 2 chunks. Of course, their data size is much smaller compared to satellite thing. They are providing time chunk, which is like this sheet of paper, and then also they are providing this middle size time also concatenate, and then also, but instead the X and Y, it's smaller here. They are providing so that the user can choose 2 sets. Yeah. Yeah, in Zarr format, yeah.
Back in the times we were talking about band sequential, band interleaved by line, and band interleaved by pixel. It's nothing else than having the same data cube, but changing the order of axis. And that gives you a respective faster axis depending on which of the dimensions is in the first place. And of course, each of them has advantages. When you work with hyperspectral data, you want sometimes the spectra to be very fast accessible, and then you put them first, and that's a BIP. All this, to me, has nothing to do with format, really, because you can store all of them in the same format. Format is really, in the sense of a cork, an NV file, or whatever, that's for me format. The exact structure, the representation is a different question. Most formats are perfectly fine in storing different representations. Like in a cork, you can store the cubes in different ways if you want. That's no problem in NetCDF, as far as I understand as well. So that's not a format question, that's a representation question. So I would have actually liked to hear a bit more about the specific format thing here. So really, how do we encode the individual files? And for example, what I think we didn't talk at all, and what is for me a very important part of formats, is the metadata. How do we store them? Which the metadata do we maintain? How do we define the hierarchy of metadata if we chunk data? Because it's very important what is defined at which level for inheritance. That has then also to do with what different kinds, how flexible are we with that, so that we can allow different chunkings, because you have to adopt your metadata structure to that. So that's rather the stuff I would really like to learn more about, the possibilities of EOF, because, and that's my last sentence, I assume the EOPF is not just for Sentinel data, and all you did so far is copy this very particular situation of a single instance acquisition by a satellite into a file structure. But we have, when we go to the services, we have much more complex data structures that will also need to fit in the EOPF. And I'm a bit worried that these might not be really considered here, as long as you always play with Sentinel data.
So the how many of you have heard about GeoZarr? Okay, so 1, 2, 3. Okay, so 4, 5. So that's kind of discussion that is going on GeoZarr. So you have a CF convention, which is very well defined. Yes. So the GeoZarr is kind of trying to combine, not perfectly, yes, but it's better than nothing, right? Yeah.
It's
Yeah.
a fundamental part of the conceptual basis, especially when it comes to gridding.
Yeah, it is, yeah. Then so, yeah. But for metadata part, yeah. So the metadata, so I come back to you later. So the GeoZarr is a kind of, so you have a stack query and so on. The GeoZarr people is kind of trying to merge. The CF convention is coming from model people, and stack is more coming from satellite people. It's my point of view. But the GeoZarr is a kind of trying to marry these two domains at the same time. Eh?
It's not from the two groups are the modelers,
yeah.
or the more the modelers and the GIS people.
GIS is more like, I call GIS people more like satellite people. Modeler is a CF convention. But anyway, yeah. So the thing, the vector, yeah. So the thing is, this GeoZarr, maybe you are there on LPS for the GeoZarr discussion, right? No, yeah. So that's I think the EOPF started their stuff. GeoZarr people, they were doing some stuff. And there's discussion now between these two. So maybe it will somehow converge at some place. That's the, yeah. And then it's true, your point is very correct that we didn't show so much about metadata today. But if you have time tomorrow, come and join us on the hackathon, and we have like all these webinar example where we show a lot of the metadata, where you can find the meta, how it is to store the metadata, how the stack catalog staff metadata is embedded in the Zarr file, which I think you would like it, to check it, to see, then I can comment on it in the discourse, right? So yeah, I really encourage lots of you to come and join us. And we have also some hackathon around DGGS here picks Zarr thematic. So if anyone is interested in DGGS, come and hack with us tomorrow. And what else was the question, discussion? Metadata, right? Other types of data. So other types of data is, I think it's the GeoZar thing. You know, how EOPF is concept is mixed with GeoZar. And then I think it's more the GeoZar which will take care of it. You don't think so? But right now, I don't have I don't know exactly what's the plan of ESA until which satellite data they want to put it in the EOPF format.
It's one CDSE. I don't want 5 different format conventions.
Yeah.
CDSE, depending on who has produced the respective thing. That's nonsense.
Yeah.
I mean, that's exactly what to overcome. Yeah. So EOPF must be fit for everything that's on CDSE. That would be my paradigm.
That I agree, and I would go one more further. It's not only European, but also Japanese data, American data. Everybody, all the data should have this something like the CF convention is a bit like that. It's like everywhere on the world. The different modelers are using CF convention, kind of, somehow. So, I mean, that's what I hope this EOPF movement will push that. Because I did see one of researcher's notebook. He is working MATLAB code. He's working with all this what was it? The John is working on altimeter. Yes, he's checking all the altimeter data of different satellite, all the work. He have if statement for each of the satellite, for all the parameters and so on. This is insane. I mean, this should be standardized, right? I think we are all in the same ground for that, and yeah, that's what I personally hope, and I think that's something I mean, yeah.
I just have a comment on this standardization. It's a very, very good idea, and I fully agree with that. But it reminds me, maybe some people know the VO table effort that has been done in astronomy. Do you know the virtual observatory effort? It was it's working, but the problem is they try to define everything. If you try to define everything, you never reach a common definition. So sometimes it's better to have a minimal common definition to work together and to accept the fact that some data has metadata that is not known by some other metadata and things like that. I mean, if we are going to try to cover every function, we will never succeed to reach some agreement. So that's my point of view, and it's just to push in another direction. But
that does not justify not to try to converge as much as possible.
yes, but we should have a date of ending.
A true justification that your data are so special that they cannot fit.
No, but I agree with you. Stop. I agree with you. Stop. My point is we should have a date to say, at this date, we take our best effort. And it's done. If we don't have date, what happened on VO table, I went to the meeting. You spend days to define if you have a capital T at temperature or a capital M at blah, blah, blah. And there are many good reasons not to do this because it's very costly. You have to change 1 petabyte of data, blah, blah, blah. So we should set, okay, we should, my requirement, I think, my point of view, is we should reach the best minimal common definition between all the data sets we will use at this date. And we come back to the next year or the year after, and you add step by step. If you don't give a date, it never happened because nothing happened, because you never reach an end. Reason. I don't blame anyone. Changing something is always costly and takes time. I'm not the ruler. It's a proposition.
But I agree in the sense that things only work under pressure.
Maybe I have more simple question. Do you use Zarr version 3 and sharding?
So EOPF right now is version 2. So if you guys, anyone is interested in Zarr version 3 and all the discussion, is a big workshop and so on in Rome on the week of 14th, no, which day? 16th? It's a 1 week, full week. Yeah, and then they're looking for funding to have a bigger room. So if anybody want to fund, ping me. So wait. Okay, the workshop. Can you Google like Zarr Rome? Yeah. Yes. You did. You are not notified. Oh, very bad. It was on Panjo Discourse. It was talking about that on Panjo Discourse. Yeah. Yeah, I know. Yeah, I know. So you found it?
Yeah, it's here.
Rome. Yeah. So that's this Zarr Summit 2024 in 25 in Rome for 1 week, and then the 13, 14, 15 is more like sprint, but 16, 17 is it's more like meeting, so that they are trying to call all the input from different users, and then they have a room, but so many people were accessing, want to come, and then the room is all full, so they are looking for like a funding so that they can add more place. So if you have any small, even smaller funding to help to have more place. At the same time, there is a Stack workshop in Foscati on the same week. So there will be like a Stack and Zarr collaborative meeting happening on that week.
Congratulations on the timing. That's the week of the CEO's biggest meeting, which is the CEO's working group that is responsible exactly for that.
Ha! Yeah.
So I don't know whom you asked there, but
Who is the organizer of this Zarr?
The organizer is Max. I can send me message. I can share you. Max Jones, yeah, Max Jones. So it's Max is from Development Cs, and Joe Hammond is the XRA the developer. So Lion Abanity will be there too, and then on Stack side, who was organizing the Stack side? I have to check. For Stack, yeah. So for Stack, I kind of complained to them, why don't they do it in the bids? Then there was a lot of people here. Then that's what I told them. They said, no, it's not possible. Yeah. No, it's the original person for organizing is not Isa, I think. It's the other, it was somebody else, but connected with Isa, yeah. Yeah. But this was pretty short notice. And I pushed them to do it in Biza. That was a...
People do need to plan their travel.
Yeah.
It's not that out of the blue
Yeah.
you create an event,
Yeah.
an important one actually.
Yeah.
And you say, and in 1 week it's already gone because the availability of the place is quite small.
Yeah, it was...
ridiculous. I mean, we have this conference here. What is so difficult in joining that?
Yeah.
I mean, what?
Yeah, I agree. I complained. Yeah.
Yeah, but why is it not simply cancelled? Why don't you? No, seriously. If we continue like that, we will have 3 or 4 communities that work in parallel on more or less the same stuff. That will all kind of develop ideas that will not be compatible. We do not make progress in this.
This Zarr thing is the Zarr developer people who are meeting by themselves.
Developing their stuff for us.
No. Well, I cannot say that because there are like a lot of NASA people or other area people that are using. You says you want to say something.
General Zarr. So it's not just geospatial. Sorry, this is not just geospatial. This is also biology. This is all kind of things.
Yeah.
So they have to figure out a common date, and that's what they said.
Yeah.
No, that's not good. That's not how it works.
Yeah.
That's just not leading to what we need.
Yes.
The project is the EOPF that you are running. How long will it last?
EOPF. Our EOPF global project. I mean, I am in a project of not like a EOPF sample service. It's not the sample service. It runs until when? We still have a half month of 6 months of a budget. Okay, so 6 months, yeah. And then toolkit, you have a budget until when?
Until April next year. And actually, I would like to introduce our part of the project for those who barely understand what's going on here. We have the basics of EOPF, which is the introduction to the Zarr standardized way of the ESA. So we really encourage you to visit our GitHub. Here you can open the issues. We also have the EOPF tooling guide, which is under development for our if I remember correctly, QGIS as well, and Julia, so stay tuned. And we have also really like step-by-step tutorials developed for each of the missions. So far, we also have on incoming different use cases on the application of the whole archive of Sentinel. So yeah, if you have any questions on the basic side, just write us and open issues on our GitHub.
Yes.
Now another question. I like to see that there are approaches to bring Zarr into GDAL and QGIS. As far as I know, they are on separate projects still, so I need to compile QGIS or at least GDAL on my own. Are there any plans to get these developments into the core GDAL project as a pull request or something like that?
This won't be in our project. We only develop this GDAL driver by ourselves. Then we create Docker images to try it out either on the Jupyter notebook. And then there will be that other Docker image where you have QGIS available already, which you can run local to test it. But no, we tried to communicate to the GDAL community, didn't get any response, and now it's basically our development phase is almost over, and we decided that we stopped this activity because it took too much time. Yeah, maybe if it gets more important, we try to push it again later on.
If I can just from our side on the toolkit, we are still trying to push to actually bring into the core GDAL and also QGIS development.
Good.
So, but this is like still like work in progress. So no, this is like the toolkit.
I will explain that.
We have like a different plugin development parts, but it's all funded by ESA, and so in the end, we just want to help or support both many communities to use EOPF data. And on our side, we still like investigated and looked like, okay, how can we actually bring EOPF star data to QGIS? But at the moment, as is already mentioned, like yeah, we still seeing because it's only making sense if we actually bring it to the core development.
So just a back explanation. So ESA is funding different projects. So one funding is for, well, as usual, and then because I mean you need a lot of people to work on it, right? So there is a people who are developing this EOPF, this meta definition, and then all this converter. That's the one big thing. And there's people like which, developing some like operational chain which relate with this thing, and then us I'm with Constantine, which are making sample service, so like converting certain data and then doing webinars and some tools with Julia and so on. And they are Toolkit, another funding, which is making another set of, you don't make webinar, or you make webinar too? I don't know, yeah. Like notebooks and also on GitHub like us. So there are so many resources that you can, try out, and then, that's what I guess ISA want to do, so that there's a lots of, like communication line like you can try out and so on. And then the main, really the community, like everybody gathers is this discourse, or if to talk to, because you don't know who to talk to for what subject, put it on the discourse, and then everybody sees it. That's that's the main channel, yeah, right? The discourse we check like a developer checks it, you guys check it, we check it. So that's the main place to. If you don't know who to talk to, if you write there, and then there is the right person who will answer the question and make the discussion. And ISA also checks that discourse too. It's code.
It's about having constructive feedback on how we can improve and make it easier for everyone. So if we are in the mood of complaining, I don't think we are making progress. To make progress, we need to have constructive feedback on what works, what doesn't work, and why it doesn't work. What can you not do with it? What do you suggest? If this is only to highlight problems, I also have thousands of problems I would like to be solved. But if we don't list what problems, what are the solutions? What problems, what are the solutions? We are not progressing. So I just want to make sure that when we have a conversation that is willing to improve and not just to say, I'm not happy because X and Y. No, because we hear a lot of people shouting from outside, and I don't think it's
That's why I asked it for the GDA integration in the past. Someone developed the Sentinel-2 driver for GDAL, and then it became quite easy to open Sentinel-2 data in QGIS and every other software that uses GDAL. And I think a similar approach would be really helpful for getting Zarr datasets uptaken.
We developed the plugin itself, but getting it really into the core of GDAL, you need to convince the GDAL community to do that. And we tried that in the beginning. Apparently, the toolkit, people are still on it. Since it's important, as I can see from this discussion, I will bring this up again in the next consortium meeting.
It's just taking time also. This is like new. The format in itself is not fully mature. Yeah. There are many things we want to improve. The metadata is not what we want. There are things that are slow because it's not like properly designed yet. But that's what the conversation we want to have. Like if you are developing a core developer of QGIS, do you want these problems to be solved first before you implement it? So I think it's very hard for them to jump in and implement from
Is that something that ESA is sufficiently supporting?
Sorry?
Is that something that ESA is sufficiently supporting? Or is there also funding?
QGIS?
Yeah, this kind of development we were talking.
Well, I think
No,
this is premature. I don't know what feeling you have for now. I mean,
So there is the wrong priority in the ESA program.
Yeah. So it's
That should be
early.
So ESA is supporting it through these projects. So basically, we are like investing now. So like we are also like part of our project, and the same as you, like we seeing, okay, what is at the moment the status?
So is it planning or a funding issue, or both?
Sorry?
Is it a planning or a funding issue, or
Like,
both?
I mean, I don't think this is a funding issue, or it's a time issue. Community-driven
Planning
project
issues are time
takes
issues.
time,
Yeah, timing.
but it's not like we don't have, we will probably need more funding afterwards for continuing these activities. But community takes time. You need to onboard, you need to discuss. We don't all agree on what would be the best way to do it.
Yeah.
Because everyone sees like the data from their own angle, and we need to have compromise, but we don't even know what are the best compromises. And this is really good that the EOPF, they are trying from like an external viewpoint, and they are trying, and they can really give more like objective feedback, because then we can see what we do not see from the inside, or what they don't see when you are building yourself the data. So I think the setting in itself is very good, but don't ask too much, because things are taking time. And feel free to contribute with your ideas, with your like positive feedback on how what is missing in the metadata. What can't you do it? What can you not do?
So what is blocking? Yeah. For example, in this case, like for example, EOPF Sentinel, and then we can, for example, start one thing about what is the timeline with the like a GDAR or integration, and so on. That's something like we can totally start, and then
But I still believe this kind of discussion about GDAR, etc. It's good to
Yeah.
make happen.
Yeah.
But it's still a bit early to have really full-fledged development, because if we change, because we got feedback this is not the proper way to do it, they have to implement again. So it doesn't really make sense.
Yeah, it's like
Now we are really in the guinea pig.
yeah, but I don't know. I mean, I like there are some people from our app which is doing a Sentinel-1 data that they really try to use this new product. But I mean, it was good that they tried, because they knew about all the different metadata. It should be said in this ways. There are certain specific ocean people which need certain data in a specific way, so they could bring in their point of view. So yes, it might change, but in my point of view, it's better if more people tries, and of course, yeah.
What is the sense of doing Zarr out of GRD instead of RTC? Because there are the shift of, it's need to be corrected to have really benefit from usage of Sentinel-1. So it's...
I didn't get it, I'm sorry.
It's a GRD.
Yeah, GRD and SLC, the Sentinel-1?
Yes.
Yeah. Okay.
Why are you producing GRD Zarrs?
Yeah.
Instead, because then you have small chunks, but we saw that in Montes, for example, there is a big shift. So maybe it's better to do RTC first.
Total crap. Sorry.
I mean, I don't know why they are choosing, but there is SLC.
RTC.
This is mathematically corrected.
But there is a single SLC data. Can we go back to the stack?
SLC is raw.
Yeah. So, for example, if there are some data, you think it's better to be. So there is Sentinel-1.
The Sentinel-1, GRD,
and SLC. So what you're saying is that they should not do this one, or they should do that.
It's
but
better
they should add it. Which
to
one?
produce RTC and do Zarr out of RTC.
Okay, that's something. Do you think you can write that on the discourse? Saying, yeah. Thank you.
There is a new CEO specification on Zarr analysis ready data that explains exactly what these kind of things should look like. Backscatter and so on, normalized backscatter in auto-rectified geometries.
Okay.
That's what they should produce.
Okay.
Because everyone else does it meanwhile with Sentinel data, but not.
That was how the safe format was done before, or it's not that?
No, that has nothing to do with the format. That's a different product level.
Product level. Yeah, so that's something.
It's a bit of a side subject.
That's something also, some kind of request I mean, what would be good, like if you have some request of this kind of data set, if you can also explain what is your use case. So then we can, for example, produce the Jupyter notebook or whatever other stuff together with this new data set, and then see how is it really like, what's the problem of this new file format? Because that's some, and then if you have certain like date and so on, that's something we can give to information EOPF sample service. They are definitely willing to make certain area, certain time for this kind of specific notebook. So that's really, we would like to have as a feedback. So which date, for example, if you already have some example, like notebook or like MATLAB, whatever, and then you wanted to try, but the data doesn't exist, write it, we can, and then put the link, and then we can try to see, you know, and that can be the next webinar's notebook and so on.
Best would be just always to
Yeah.
get us the stuck item ID basically to track it back.
Yeah. So if that's data that you want to try for your example doesn't exist, please don't hesitate to write it so that we can try to make it. And then like your product doesn't exist, please write it on this Discord. Yeah. I mean, of course you can write it on sample service. I mean, I think it's better with this one. It's better. This is, then it's information is centralized, so it's.
I probably not to the sample data, because the EOF sample project is focused on conversion itself.
No, not only conversion. We are also doing a notebook example. My work there is picking up some scientific notebook and then try with the sample service and then explain the metadata, how to find the metadata, how to transform the workflow and so on. So it's not only the converting. Yeah. But it's better if you write it on this course, you will arrive in the right place. And then, This code, I mean, yeah. Because there's so many people working in a, yeah, because otherwise I think it's so complicated for users to know, okay, if this I have to make there, if this I have to make there, I mean, I think.
Yeah, I think it's a good way of filtering issues, because half of them will never arrive.
But we want to arrive there,
I will. You know, on GitHub, on this UPS pooling.
What's your name?
And then we have
Very interesting now, because we saw all the data and we are thinking how we can convert this data with the format. How we can store such a massive.
Yeah.
Because those really, if you take those files, those chunks, they're really small. And object storage is very valuable.
So that's why the sharding is very important for the, yeah.
And then
we are looking at that also.